Jupiter stands as the mighty ruler of the solar system, unmatched in size, force, and influence. It is more than a planet. It's a cosmic powerhouse that helps shape the movement of everything around it. This giant world is made of gas, has no solid surface, and spins faster than any other planet. Its swirling atmosphere is filled with storms, including one larger than Earth that has raged for centuries. Jupiter's powerful gravity controls the paths of moons, comets, and asteroids, and even protects Earth from deadly space objects. With its dozens of moons, hidden rings, and a magnetic field that stretches millions of kilometers, Jupiter operates like a system of its own. Each moon has its own personality, and some may even hide oceans that could support life. Understanding Jupiter is like unlocking the early history of the solar system and discovering how giant planets shape everything around them. Jupiter is so massive that it outweighs all the other planets in the solar system combined. Its diameter is about 143,000 kilometers, making it more than 11 times wider than Earth. This means over 1,300 Earths could fit inside Jupiter's vast volume. In terms of mass, Jupiter is more than 318 times heavier than Earth, giving it the strongest gravitational pull of any planet. Its huge size plays a major role in shaping the solar system. It has prevented other planets from forming in the asteroid belt, and it influences the paths of comets and space rocks. Jupiter's gravity is strong enough to fling objects away or capture them as moons. If Jupiter had been slightly more massive, it could have become a star, since it is mostly made of hydrogen and helium, the same materials as the Sun. Scientists believe Jupiter formed early in the solar system's history, grabbing most of the leftover gas and growing quickly. Its great mass also causes high pressure deep inside, creating strange forms of matter like metallic hydrogen. Because of this pressure, Jupiter has an intense magnetic field and powerful weather systems. Its size is not just impressive, it is essential to understanding how planets shape their surroundings. Jupiter is a gas giant, meaning it does not have a solid surface like Earth or Mars. Its composition is mostly hydrogen and helium, the two lightest and most common elements in the universe. These gases form thick layers that stretch deep into the planet. As you go down, the pressure increases so much that hydrogen gas is compressed into a dense liquid. Deeper still, the pressure turns this liquid into metallic hydrogen, a rare and exotic form that can conduct electricity. This material is believed to power Jupiter's strong magnetic field. Jupiter might also have a core made of rock and metal, but it is hidden beneath thousands of kilometers of gas and liquid, making it very hard to detect. The outer layer of the atmosphere is made of clouds of ammonia and other gases that swirl into the colorful bands we can see. Jupiter's deep atmosphere contains no solid ground to stand on. Any spacecraft that tried to land would be crushed and melted long before reaching the core. Jupiter's gas composition gives it unique weather patterns and allows it to produce enormous amounts of internal heat. This heat rises through the layers, creating storms and winds that help shape Jupiter's wild atmosphere. Jupiter's Great Red Spot is a storm so big that it could swallow Earth. It has been spinning in Jupiter's southern hemisphere for over 350 years. This giant oval-shaped cyclone is made of high-pressure gas rotating counterclockwise. Its size has shrunk over time, but still stretches more than 16,000 kilometers wide. Winds inside the storm reach speeds over 400 kilometers per hour. The color of the storm ranges from dark red to light orange and changes slowly, likely due to sunlight interacting with chemicals in the upper atmosphere. The storm's enormous power comes from Jupiter's fast rotation and heat rising from deep inside the planet. It sits between two bands of clouds moving in opposite directions, which help keep it spinning. Unlike hurricanes on Earth, which need oceans, the Great Red Spot draws energy from Jupiter's atmosphere. It rises higher than surrounding clouds, which is why it's visible from Earth through telescopes. The exact reason why it has lasted for centuries remains a mystery, but it offers clues about how weather works on gas giants. The Great Red Spot is more than just a storm. It's a symbol of Jupiter's extreme nature and a powerful reminder of the forces shaping this planet's turbulent skies. Jupiter spins faster than any other planet in the solar system, completing a full rotation in just under 10 hours. This rapid rotation causes the planet to bulge at the equator and flatten at the poles, giving it a noticeable oblate shape. The fast spin also plays a major role in Jupiter's weather. It stretches the planet's atmosphere into colorful bands that wrap around its entire surface. These bands are created by powerful jet streams that blow in opposite directions and stir the gases into stripes. The difference in rotation speed between Jupiter's equator and its poles creates zones of turbulence, where storms and vortices can last for years. The fast rotation helps drive the enormous energy systems inside the planet, mixing heat from the core and helping to maintain the magnetic field. It also influences the shape of the planet's magnetosphere and how it interacts with the solar wind. Because of this high speed, the clouds on Jupiter shift quickly, creating ever-changing patterns. The speed of rotation has been measured by tracking radio emissions from Jupiter's magnetic field, which rotate along with the planet. Jupiter's short day makes it an extremely active world full of swirling motion, spinning clouds, and rotating storms. Jupiter has the strongest magnetic field of any planet in the solar system. It is more than 20,000 times stronger than Earth's. This powerful field is created by the motion of metallic hydrogen deep inside the planet. As the planet spins rapidly, it stirs the electrically conducting fluid, generating a magnetic field through a process called the dynamo effect. The magnetic field extends millions of kilometers into space, creating a massive magnetosphere that surrounds Jupiter and traps high-energy particles. This magnetosphere is shaped like a teardrop with a long tail stretching away from the sun. Inside the magnetosphere are intense radiation belts filled with dangerous particles. These belts are so strong that they can damage spacecraft and even destroy electronics if not properly shielded. The magnetic field also creates brilliant auroras at Jupiter's poles, where charged particles spiral into the atmosphere. These auroras are much more powerful than Earth's northern and southern lights and glow constantly. The field also interacts with Jupiter's moons, especially Io, which contributes material that gets trapped and electrified. Studying Jupiter's magnetic field helps scientists understand magnetic processes on other planets and even distant stars. Jupiter's magnetism is a force of nature, shaping everything that comes near its massive reach. Jupiter has a faint ring system that was discovered in 1979 by NASA's Voyager 1 spacecraft. Unlike Saturn's bright and icy rings, Jupiter's rings are made mostly of tiny dust particles that reflect very little light. This makes them hard to see with telescopes from Earth. The ring system has three main parts: a wide and faint halo ring closest to the planet, a narrow main ring, and two thin gossamer rings farther out. These rings are not permanent structures. They are formed from dust knocked off Jupiter's small inner moons by micrometeorite impacts. When space rocks hit the surfaces of these moons, dust is blasted into orbit and slowly spreads out to form the rings. Over time, the dust either falls into Jupiter or drifts away, meaning the rings are constantly being refreshed. The particles are small and dark, mostly made of rock rather than ice. Although they may not be as dramatic as Saturn's rings, Jupiter's rings offer important clues about how dust behaves in space. Jupiter's rings may be faint, but they are part of a larger system that includes moons, magnetic fields, and radiation, all connected by gravity and motion. Jupiter has more known moons than any other planet, with at least 95 confirmed so far. These moons come in many shapes and sizes, from tiny rocks only a few kilometers wide to massive moons larger than the planet Mercury. The largest and most famous moons are the four Galilean moons, Io, Europa, Ganymede, and Callisto, discovered in 1610. Each moon has a unique surface, composition, and internal structure. Some are volcanic, some icy, and some may even have underground oceans. The smaller moons of Jupiter often have irregular orbits and are thought to be captured asteroids or fragments from ancient collisions. These moons orbit at various distances, with some very close to Jupiter and others far away. The outer moons tend to be clustered in groups and can orbit in the opposite direction of Jupiter's spin. The gravitational pull of Jupiter affects their motion, and in turn, some moons influence each other through orbital resonances. These interactions create internal heat, reshaping the surfaces of several moons. Scientists are especially interested in the larger moons for what they can teach us about planetary formation, geology, and the possibility of life in other places. Jupiter's moons form a miniature solar system of their own, rich in mystery and discovery. Discovered by Galileo Galilei in 1610, These moons were the first objects found orbiting another planet, challenging old ideas about the universe. Io is the most volcanically active place in the solar system. Its surface is covered with lava flows, and eruptions are constantly reshaping its colorful landscape. Europa has a smooth, icy crust that hides a deep saltwater ocean beneath. Scientists believe this ocean could support life, making Europa one of the most exciting places to explore. Ganymede is the largest moon in the solar system and even has its own magnetic field, a rare trait for a moon. It may also have a buried ocean. Callisto is ancient and covered in craters, preserving the history of impacts over billions of years. These moons are very different from one another, showing how varied the worlds around gas giants can be. They are not just satellites, they are active, evolving bodies with geology, chemistry, and in some cases, the potential for life. The Galilean moons have inspired future missions, including NASA's Europa Clipper, which will study Europa's ice and ocean in great detail. Jupiter's surface is wrapped in colorful bands and zones that stretch around the planet like wide ribbons. These patterns are caused by high-speed jet streams moving in opposite directions at different latitudes. The light-colored zones are made of rising gas that forms cold, high-altitude clouds. The darker belts are areas of sinking gas that are lower and warmer. These bands are full of turbulence and swirling motion, especially where they meet. The constant flow of gases creates spots, storms, and eddies that change over time. Jupiter's rotation and internal heat help power these jet streams, pushing the gases into motion. The exact colors come from chemical reactions involving compounds like ammonia, sulfur, and phosphorus in the atmosphere. The bands are not just decoration. They reveal the complex behavior of Jupiter's weather system. Over time, bands can shift, split, or merge, showing that the planet's atmosphere is always active. By studying these bands and zones, scientists learn about atmospheric circulation, pressure systems, and gas movement on a giant scale. Jupiter's striped appearance is more than beautiful. It's a constantly changing record of deep winds, rising heat, and powerful weather on a planet made almost entirely of gas and energy. Jupiter's auroras are the most powerful and long-lasting light displays in the solar system. These glowing rings appear near the planet's north and south poles and are created when high-energy particles crash into Jupiter's upper atmosphere. The planet's strong magnetic field channels these particles, causing them to spiral into the poles and produce ultraviolet light. These auroras are much stronger than Earth's northern lights and can last for days or even weeks. Jupiter's auroras are partly powered by the solar wind, but also by the planet's own internal rotation and its moon Io. As Io orbits Jupiter, it releases particles that become trapped in the magnetic field and help generate electric currents. These currents flow along magnetic lines and cause brilliant auroral flares. Unlike Earth's auroras, which appear mostly during solar storms, Jupiter's are almost always active. Scientists study these lights using special telescopes that can detect ultraviolet and X-ray energy. Jupiter's auroras offer insight into how magnetic fields and charged particles interact. They also help researchers understand the behavior of giant planets and their environments. These lights are more than a visual wonder. They are electric fingerprints of Jupiter's power, showing how invisible forces can shape and illuminate a world. Deep inside Jupiter, a powerful and complex structure hides beneath the colorful clouds. Scientists believe that the planet may have a dense core made of rock, metal, and ice. This core could be surrounded by layers of metallic hydrogen, a rare state of matter that acts like a liquid metal under extreme pressure. Above that is a massive layer of liquid hydrogen and helium, which gradually turns into gas as it rises toward the surface. Jupiter's internal heat comes from energy left over from its formation and from the slow compression of gas under gravity. This heat moves outward, creating strong convection currents that drive the planet's winds and storms. Unlike Earth, where layers are clearly separated, Jupiter's interior may be more mixed, with a blurry boundary between the core and the rest of the planet. The Juno spacecraft is helping scientists learn more about the interior by measuring changes in gravity and magnetic fields. This data helps map what lies beneath the clouds without actually going inside. Understanding Jupiter's inner layers reveals how gas giants form and evolve. It also gives us a model for studying other massive planets in our solar system and beyond, unlocking secrets buried in deep pressure and heat. Jupiter is believed to have formed very early in the history of the solar system and played a major role in shaping everything that followed. Its massive gravity influenced the movement of gas, dust, and rocks in the solar nebula, the cloud of material left after the Sun's birth. As Jupiter grew, it pulled in huge amounts of gas, becoming the largest planet and clearing out its path. This strong gravitational force affected nearby forming planets, pushed some material into the inner solar system and flung other objects far away. Some scientists believe Jupiter may have helped deliver water to Earth by altering the paths of icy bodies. Jupiter also stopped a planet from forming in the asteroid belt by constantly disturbing the orbits of rocks in that region. Without Jupiter, the arrangement of the planets might be completely different. It may have helped protect the inner planets from destructive impacts by deflecting comets and asteroids. Its influence continues today, keeping space organized and balanced. Jupiter's early movements and massive presence acted like an architect of the solar system, deciding what could grow, where, and how bodies would interact. It shaped the planetary lineup and helped create the safe environment we live in today. Jupiter is surrounded by intense belts of radiation that make it one of the harshest environments in the solar system. These radiation belts are regions filled with charged particles, mainly electrons and protons, that are trapped by Jupiter's powerful magnetic field. The belts are strongest near the equator and can extend millions of kilometers into space. These particles move at nearly the speed of light and create dangerous conditions for spacecraft and electronics. The radiation is much stronger than the belts around Earth and can destroy unprotected instruments. Space missions like Galileo and Juno must use special shielding to survive in these zones. Some of the radiation comes from the solar wind, but much of it is supplied by Jupiter's volcanic moon Io, which sends gas into space that becomes ionized and trapped. These belts also create radio waves and contribute to auroras at the poles. Scientists study Jupiter's radiation to understand space weather and protect future missions. The belts reveal how magnetic fields work around gas giants and how energy moves through space. Jupiter's radiation belts form an invisible storm of power circling the planet, reminding us of the intense forces that exist beyond Earth's protective shield. Jupiter plays a protective role in the solar system by helping shield Earth from dangerous space rocks. Its strong gravity acts like a cosmic vacuum cleaner, pulling in or redirecting comets, asteroids, and other debris that might otherwise strike our planet. One of the clearest examples of this happened in 1994 when fragments of comet Shoemaker Levy 9 collided with Jupiter. The impact left massive scars on the planet's atmosphere, visible even through telescopes on Earth. If that comet had hit Earth instead, the damage would have been catastrophic. Scientists believe that without Jupiter's presence, Earth might have experienced many more devastating impacts over time. Jupiter's gravity affects the orbits of countless objects, either capturing them as moons or flinging them out of the solar system. This constant sweeping helps keep the inner solar system, where Earth orbits, relatively safe. Some researchers even suggest that Jupiter's early formation allowed life to eventually evolve on Earth by reducing the number of major impacts during our planet's history. Studying how Jupiter affects incoming space objects also helps us understand how to protect Earth from future threats. Jupiter's role is silent but essential. It stands like a giant guardian, its mass keeping us safe from dangers that fly through space. Jupiter orbits the Sun at a distance of about 778 million kilometers, making it the fifth planet in the solar system. It takes nearly 12 Earth years to complete one orbit, giving it a very long year compared to Earth. Its orbit is slightly elliptical but still fairly circular, which helps keep the planet's motion stable over time. Jupiter's orbit lies close to the same plane as the other planets, and its axial tilt is small, so it doesn't have noticeable seasons like Earth does. The planet's massive gravity affects many objects around it, including asteroids, comets, and nearby planets. Jupiter's presence has helped maintain the structure of the asteroid belt, keeping it from forming into a planet. Its orbit also includes special regions called Lagrange points, where thousands of Trojan asteroids travel alongside it, either ahead or behind in the same path. These objects are stable companions that have likely been with Jupiter for billions of years. Jupiter's movement through space isn't just about its own path. It also guides and stabilizes the motion of other objects. Its orbit acts as an invisible force, shaping the solar system's layout and influencing the dance of planets, rocks, and dust around the Sun. Jupiter's magnetosphere is the largest and most powerful magnetic environment in the solar system. It is a giant bubble of magnetic field lines and charged particles that extends millions of kilometers into space. This massive structure is created by the planet's internal movement of metallic hydrogen and its rapid rotation. Within the magnetosphere is an area called the plasma torus, a glowing ring of charged particles surrounding Jupiter, mostly contributed by the volcanic moon Io. Io ejects gases like sulfur and oxygen, which become ionized and trapped in the magnetic field. These particles form a donut-shaped cloud that rotates with the planet. The magnetosphere also generates strong radio emissions and powers intense auroras at the poles. The energy and size of Jupiter's magnetosphere are so extreme that it would appear larger than the sun in the sky if it were visible. The magnetosphere protects Jupiter from solar wind, but also creates a harsh radiation environment that spacecraft must avoid or shield against. This system interacts with many of Jupiter's moons, especially Io and Europa, creating electric currents and plasma waves. Studying Jupiter's magnetosphere and plasma torus helps scientists learn how magnetic forces work on giant planets and across the universe. Beneath the icy surface of Europa lies one of the most promising locations to search for alien life. Europa, one of Jupiter's Galilean moons, is believed to hide a global subsurface ocean beneath its frozen crust. The ice on the surface is smooth and crisscrossed with cracks and ridges, suggesting that it floats over a layer of liquid water. This ocean is kept warm by tidal heating. Gravitational forces from Jupiter and neighboring moons cause Europa's interior to stretch and flex, creating heat through friction. The ocean may contain more water than all of Earth's oceans combined, and it could remain liquid due to this constant internal warmth. Scientists believe that hydrothermal vents on the ocean floor, like those found on Earth, could provide the conditions needed for simple life. Future missions like NASA's Europa Clipper will explore Europa's surface and analyze its composition, searching for signs of habitability. Some regions even show signs that water from below may have reached the surface, leaving behind possible chemical clues. Europa's hidden ocean remains one of the most exciting frontiers in planetary science. It is a frozen world with a liquid heart where water, energy, and chemistry may come together in the conditions needed for life. Io is the most volcanically active body in the entire solar system. This fiery moon of Jupiter is constantly reshaped by eruptions that blast lava and gas hundreds of kilometers into space. Unlike Earth's volcanoes, Io's eruptions are fueled not by plate tectonics but by immense tidal forces. As Io orbits Jupiter, it is pulled and squeezed by the planet's gravity as well as by the gravity of neighboring moons Europa and Ganymede. This constant stretching creates internal friction that heats Io's interior and melts rock into magma. The result is a landscape covered in lava lakes, volcanic plains, and giant eruption plumes. Some volcanoes on Io erupt with such force that their effects can be seen from orbit. The surface is coated in colorful sulfur compounds, giving Io its yellow, orange, and red appearance. Its thin atmosphere is made mostly of sulfur dioxide, escaping constantly into space. These volcanic gases help form Jupiter's plasma torus, a glowing ring of charged particles around the planet. Io's extreme geology makes it an exciting target for future missions. It shows how powerful tidal forces can shape a moon into a world of fire, heat, and never-ending activity, completely different from any other place in the solar system. Ganymede is not only the largest moon in the solar system, but it is also the only moon known to have its own magnetic field. Larger than the planet Mercury, Ganymede is a giant icy world with a rocky core and a suspected underground ocean. Its magnetic field is thought to be generated by a liquid iron or salty water layer deep inside. This internal motion creates a magnetic bubble that interacts with Jupiter's larger magnetosphere. When these two magnetic fields meet, they create auroras near Ganymede's poles and cause fluctuations that scientists can measure from orbit. The Galileo spacecraft detected this magnetic field during flybys in the 1990s, and the Juno mission continues to explore its effects. Ganymede's surface is a mix of older cratered regions and newer grooved terrain, possibly caused by past tectonic activity. The magnetic field adds another layer of complexity to an already fascinating moon. It suggests an active interior and possibly even a layered structure similar to Earth. Studying Ganymede helps scientists understand magnetic fields, planetary geology, and the evolution of icy moons. Its magnetic personality sets it apart in a system already full of surprises. Ganymede is not just big, it's magnetic, dynamic, and full of potential for discovery. Callisto is one of the oldest and most heavily cratered objects in the solar system. This large moon of Jupiter has a dark, icy surface covered with scars from billions of years of impacts. Unlike Io or Europa, Callisto shows no signs of recent geological activity. Its ancient surface has remained largely unchanged, preserving a record of its violent history. The largest impact feature on Callisto is Valhalla, a massive crater with concentric rings that stretch across thousands of kilometers. These features suggest that the surface is made of a mixture of ice and rock, allowing it to flex and ripple when struck. Callisto's interior is not believed to be as active as other Galilean moons, but some studies suggest it might still hide a salty ocean deep beneath the crust. The moon has a thin atmosphere of carbon dioxide and possibly oxygen, but it is far too thin to support life. Callisto's quiet nature makes it an ideal target for missions needing less radiation exposure, such as potential future human missions to Jupiter's moons. It is a frozen relic of the early solar system, a natural museum of ancient impacts. Its battered surface tells the long story of survival in a violent cosmic neighborhood. Jupiter's powerful gravity plays a major role in shaping the asteroid belt, a region of rocky objects that lies between Mars and Jupiter. Instead of forming into a planet, the material in the asteroid belt was constantly disturbed by Jupiter's presence. Its strong gravitational pull prevented the rocks from coming together, keeping them scattered across space. In certain regions of the belt, Jupiter's gravity creates gaps known as Kirkwood gaps. These are areas where the gravitational influence of Jupiter pulls objects out of their orbits, leaving fewer asteroids behind. The planet also causes orbital resonances, where asteroids move in sync with Jupiter's orbit and become unstable over time. Some of the objects that are ejected may fall towards the inner solar system or be flung out into deep space. Jupiter's influence keeps the asteroid belt in its place and helps maintain the balance of the solar system. Without it, the belt might have formed a fifth rocky planet or become more chaotic. By studying how Jupiter affects the motion of these space rocks, scientists gain insight into how large planets shape the environment around them. Jupiter acts as a giant space sculptor, carving paths and keeping the asteroid belt in check. Jupiter shares its orbit with two groups of Trojan asteroids that stay in stable zones ahead of and behind the planet. These ancient rocks have remained undisturbed for billions of years, offering clues about the early solar system. NASA's Lucy mission is exploring several of them to learn more. Jupiter also assists space missions through a gravitational slingshot, boosting spacecraft speed using its massive gravity. This technique has helped missions like Voyager and New Horizons travel farther using less fuel. Jupiter silently supports exploration, both by holding cosmic history in its orbit and by flinging spacecraft deeper into space. Jupiter has been visited by several spacecraft that revealed stunning details about its atmosphere, moons, rings, and magnetic field. The first close encounter came from Pioneer 10 in 1973, followed by Pioneer 11. Then came the Voyager 1 and 2 missions in 1979, which captured spectacular images and discovered Jupiter's ring system. In 1995, NASA's Galileo mission became the first to orbit Jupiter and released a probe into the planet's atmosphere, giving direct data about temperature, pressure, and winds. Galileo studied Jupiter for years, revealing volcanic activity on Io and strong signs of an ocean under Europa's ice. In 2007, New Horizons passed by Jupiter on its way to Pluto, using the planet's gravity to gain speed and taking more measurements. In 2016, NASA's Juno spacecraft began orbiting Jupiter. It continues to study the planet's deep interior, gravity, magnetic field, and auroras. Future missions like Europa Clipper and the European Space Agency's JUICE mission will focus on Jupiter's icy moons, especially Europa and Ganymede. Every mission helps scientists better understand how gas giants work. Jupiter's exploration has turned it from a distant dot in the sky into a rich, active world full of surprises, with many more discoveries still to come. Jupiter is more than just a giant planet. It is a key player in the history, structure, and future of the solar system. Its enormous size, powerful gravity, and dynamic atmosphere make it one of the most fascinating places to study. From protecting Earth from space debris to shaping the orbits of asteroids and influencing other planets, Jupiter's reach extends far beyond its cloudy surface. Its many moons offer a wide range of environments, some of which may even support life. Each mission to Jupiter uncovers more secrets, showing that this planet is not just massive but deeply complex. Whether through storms, magnetic fields, or ancient rocks riding along its orbit, Jupiter continues to amaze scientists and inspire curiosity. To understand Jupiter is to understand the forces that shape planets, moons, and space itself. It is the mighty guardian of our solar system, always active, always mysterious, and always waiting to be explored.